Jai Hind everyone. My name is Amrita Bhatnagar. I am Assistant Professor in Computer Science in AKGEC College. Today I am going to explain instruction cycle, which is the part of the Unit 3 in computer organization. Firstly, we will understand what are the main content of this lecture. You can understand here. Firstly, we will understand what is the meaning of instruction cycle. Second one is basic computer instruction types. What are the different type of instruction can be possible? And third one is control unit of basic computer. And then we will understand the complete execution of the instruction. Fine. Firstly, we should understand what is the introduction. What is the meaning of instruction cycle? A program residing in the memory unit of the computer consists of sequence of instructions. These instructions are executed by processor by going through a cycle for each instruction, and this cycle is known as a instruction cycle. Okay, so when we write a program, then it will store in the memory unit. For example, you can see here, for example, this is your main memory. When you write a program in the main memory, the instruction will be stored in the main memory. For example, this is the one instruction which is stored in the main memory. But when it will be executed, then this instruction will be come into the CPU for the execution. Fine. In the CPU, we will have registers where we can store the instruction. Okay, so firstly, the first step for the instruction execution is fetch the instruction from the memory. So in this case, we will fetch the instruction which is stored in the main memory. This is the main memory, and we will fetch the instruction from the main memory. So firstly, this instruction will be come to the CPU, and in the CPU, it will come into the instruction register. IR is the name of the register where this instruction will be stored. When this instruction will came into the CPU, then first phase is completed, which is known as a fetch instruction from memory. Now the next part of the next cycle of subcycle of the instruction cycle is decode the instruction. Now the question is, what is the meaning of decoding of the instruction? Decode mean what is the meaning of this instruction? It can be any operation which is performed in the instruction like load, add, subtract, multiplication. So we should decode the instruction so we can find out the operation of the instruction, and this is decoding will be done by the control unit in the CPU. Fine. So second step is the decoding of the instruction. Third is the read the effective address from the memory. Now we have to find out the effective address of the operand. For example, this is one instruction. You can see here, this is the one instruction. This is the opcode part. So at the time of decoding, this opcode part will tell us what is the operation of the instruction. And next is the address part. And this address part will tell us this operation will be performed on which operands. For example, if we want to perform A plus B, then plus is the operation which is told by the opcode. After the decoding this instruction, we have to perform addition, and A and B are the operand on which this operation will be performed, and these A and B will be stored in the memory. So we have to find out the address of A and B, which is known as a effective address. The meaning of the effective address is address of the operand. So here the address of the operand will be A, or address of the A or address of the B. So in the third step, we will find out the address of the operand, and the last one is the execute the instruction. Okay, in the last step, we will execute the instruction. Now there is one possibility also here. In the effective address, there can be two type of addressing, indirect or direct addressing. If the direct addressing will be done, then directly from the memory operand will be find out, and if the indirect addressing is there, then we have to find out the address to the another address. We will give in the address part, there is a, for example, 010 address is given, and when we go to the 010, then again we will find out another address, and when we go to 110, then we get the operand. This is an indirect addressing. So there may be possibility of two type of addressing, direct or indirect addressing. So by the help of mode bits we can find out the effective address of the memory. And in the last step we will execute the instruction. When we find out what is the operation of the instruction, what are the effective address of the operand, when we have all the information about the instruction, then this instruction will be executed by the help of ALU or CPU. Fine. So this is the main steps of the instruction cycle. These 4 steps are the main steps of the instruction cycle by which we can execute a particular cycle or particular instruction, or this first step will be always repeated for the each and every instruction. So when we complete a particular execution of a particular instruction, then one instruction cycle will be completed and next instruction cycle will be started for the new instruction. So all these phases will be passed by the instruction, each and every instruction. That's why it is known as an instruction cycle. So you can see here, this cycle will be always for the run for the each and every instruction. First one is the fetch instruction, decode instruction, read the factor address from the memory, and last one is the execute instruction. This is like a cycle which will be repeated for the each and every instruction in the program. Fine. Now the different type of instruction can be possible here. Basic computer instruction type. First one is your memory reference instruction. Now the question is, what is the meaning of memory reference instruction? These instructions refer to memory address as an operand. The other operand is always in the accumulator. Specify 12-bit address, 3-bit opcode and 1-bit addressing mode for direct. Now you can see here, this is the instruction format. Now this instruction, in the instruction format, instruction is divided into 3 parts. First one is your mode bit, where the value of I, what it means, if the value of I is equal to 0, what it means, this is the direct addressing. If the value of I is equal to 1, it means it is the indirect addressing. So firstly, in the instruction instruction is divided into 3 parts. First one is the mode bit, second one is the opcode bit. When we have 3 opcode bit, what it means, we can perform 8 operation, because 2 raised power 3 operation can be performed, because we have given 3 bits for the operand. Now this is the part of the memory address. Now what is the use of memory address? This is a part for the find out the address of the operand. For example, we are going to perform A plus B. So plus will be tell by the opcode. This is the operation of the instruction. First operands is in the accumulator, which is already given in this example, and second operand B, B address will be stored in the memory address part. So always this, in the case of memory reference instruction, operand B will be stored in a particular memory address, not a register. Always it will be in a memory. That's why it is known as a memory reference instruction. So if we see all the combination of 0000 to 111, then you can see here only 111 is used for the other type of instruction, and all the 002 other part will be used for the memory reference instruction. Okay, so you can see here memory reference instruction. In the memory reference instruction, we have 12 bit of memory address and 3 bits for the opcode and 1 bit for the direct indirect bit or mode bit. Fine. So this is the memory reference instruction. In the memory reference instruction, always we have memory address and the address part. Next is the register reference. Now if the value of opcode is 111, what it means, it can be a register reference instruction. And the another thing is the 15 bit or mode bit should be 0 here. If the combination of the mode bit and opcode bit will be 00111, then it can be a register instruction, register reference instruction. What it means, register reference instruction, in the address part we have a register address. So or what it means the operand is stored in a particular register now, not in the memory. If the operand is stored in the register, then it is known as a register reference instruction, and the combination for the register reference instruction is 0 1 1 1. Always remember it. And the next one is the next type is input output, where we have the combination of 1 1 1 1. Code value will be 1 1 1, but the direct indirect bit, which I have already told you, this is the mode bit, it will be 1. So if the combination of the mode bit and the opcode bit is 1 1 1, then what will be happen? Then the input output instruction can be possible. Input output instruction means, for example, if you want to take the input from the user, so if you are connecting any input output device to the CPU, then this instruction will be executed. For example, you want to take the input from the keyboard. So if we execute the instruction, and then system will be connected to the a particular input device, and it will take the it will give the address of the input device. So in this case we will have input output operation, or input output as address will be there. So we have three types. So we have seen here we have three type of instruction: memory reference instruction, register reference instruction, and input output instruction. Now this is the diagram of the control unit. Now we should understand the complete execution of the instruction or instruction cycle. We should understand the role of the control unit also. We have control unit in the CPU, which perform the overall control on the all the operation of the CPU. Fine. So in this case you can see here the instruction again divided into three parts, where we have 0 to 11 for the address part, 12, 13, 14 bits are used for the opcode part, and 15 bit is used for the direct indirect bit. Fine. So you can see here this is the diagram of the control unit, and control unit can be implemented by the hardware and software also. When we are using hardware, then it is known as a hardwired control unit. So this is the case of hardwired control unit we are showing here. Fine. So you can see here this is the decoder. 3:2 decoder is used to decode the instruction. We have to find out the which operation has to be performed. If we have 3 bits of opcode, what it means, 2 raised to the power 3 operation can be performed. It means 8 operation can be performed. So which operation will be performed in particular opcode? Then this is decoded by the decoder. So we have 3:8. Decoder here. If the value of opcode is 0 0 0, what it means, 0 output will be 1 and other output will be 0. So this is the functionality of the decoder. Only one output will be 1 at a time. So if the value of the opcode is 0 0 0, then the 0 output will be 1. So that operation will be performed by the CPU. If the value of the decoder opcode is 0 0 1, then 1 output will be the 1. So in this way we can find out which operation is performed. So you can see here D0 to D7 output lines will be here, and it is going to the control logic gates, which is a control unit, and this control unit will perform control signals. Will give the control signal. It will decode the decoder will decode the all the instructions, and then given to the control logic gates or control unit, and then it generates the control signals here. Now you can see here this is another decoder 4:16 and 4-bit sequence counter. Now these all the hardware is used for the find out the timing signal. For example, this is a 4:16 decoder, so it can generate 15 outputs. Okay, it means we can generate T0 to T15 timing signals. To generate to active the timing signal T0, we have to given here the input 0 0 0. So we have connected with a counter, sequence counter, 4-bit sequence counter. The 4-bit sequence counter will generate a sequence of the numbers 0 0 0, 0 0 1, 0 1 0. And in this way it will give the input to the decoder, and timing signal will be generated like firstly it will generate T0, T1, T2, T3 all the time of instruction cycle. When the instruction cycle will be completed, then the timing signal again come to the 0, and the value of here we can give clear value, and again sequence counter will be start from the 0. So, in this way this hardware component or hardwired control unit can be generate control signal after the decoding of the particular instruction. Now, this is the complete execution of the instruction. You can see here. Firstly, you can see here first sequence counter, the value of the sequence counter is 0 here. Now, when the sequence counter value is 0, then the first timing signal will be generated T0. In the T0, what will happen? In T0 program counter, the value of the program counter will be transferred to the address register. Now, the question is, what is the value of in the program counter? Program counter will store the value of next instruction is to be executed. What it means, which instruction is going to execute, the address of the instruction will be stored in the program counter. So, this program counter will provide the address to the AR. When AR will have AR is for the address register, then from this particular address, memory address, in the next timing signal it will be T1. In the next timing signal on the from the particular memory address, the instruction will be fetched into the IR, where IR is your instruction register, which we have already told you. So, and the value of the program counter will be increased here +1, because now the program counter will show the address of the next instruction, because now this instruction is transferred to the CPU. Now, program counter will be show the next instruction is to be executed, because this instructions execution is started down. Now, next is the timing signal is T2. Now, in the T2, now we have from the up to the T1 we have completed a fetch phase, and in the T2 phase what will happen? Instruction register address 0 to 11 transfer to the address register. What it means? Now, we are going to decode the opcode. So decode opcode is 12 to 14 bits are from the opcode, and it will decoded by the decoder. We have already discussed it. Now, the next part of the instruction register 0 to 11, which is the address part, is transferred to the address register, and IR 15 bit, which is the direct bit, will be transferred to the I flip flop. Okay. So, now we have completed here decoding part also. Now, we will find out the which type of instruction is here. So, how we can find out? This is the memory reference instruction, this is the input output reference instruction, this is the register reference. So, we have to find out D7 here. If the D7 value is 1, D7 is for opcode 111. So, I have already told you, if the value of value of the opcode is 111, so it can be a register reference or input output instruction, not memory reference. So, if the value of D7 is 0, then only memory reference instruction can be possible, and then we will find out the addressing mode. If the addressing mode I is value is 0, then the addressing will be done by the direct mode, and if the I value is 1, then addressing is done by the indirect mode. So, you can see here, if the direct mode, then there is no need to do anything in the T3 timing signal, and if the indirect mode is there, then there will be one more step where we find out the address of the read the address of the effective address, right? And then after that, the execution of the memory reference instruction will be done, and the again sequence counter become the 0 to start the next instruction. So, this is the first case where the value of the D7 is 0. Then what will happen? Now, if the value of D7 is 1, then what will happen? Then there is a possibility the instruction can be register or input output. For example, you can see here, if the value of I is 1, then it will be a input output instruction, because the output opcode value will be same, but the from the find out the value of I, we can find out it is a input output or register reference instruction. So, if the value of I is 1, then input output instruction. If the value of I is 0, then the register reference instruction will be there. So if the register reference instruction is there, then we will execute the register reference instruction, and again sequence counter will be 0. Okay. If the value of I is 1, then this is the input output instruction, then we will execute input output instruction, and last we will store the again clear the value of the sequence counter to 0, so that the next instruction can be started and the timing signal generate again from the T0. So that we can see here in the T4 or T3 timing signal, we have completed the overall execution of a particular instruction here. After that, again the sequence counter will be 0, and again the T0 timing signal will be generated for the next instruction. So always this instruction cycle will be followed by the each and every instruction. Okay. So this instruction cycle is very important in the execution of instruction. These all the phases are same for the each and every instruction. It can be a input output instruction, can be a register instruction, it can be a memory reference instruction. So these all the steps will be same for all the instructions. Okay. So this is the instruction cycle and sub cycle of the instruction. So I think you have understand it very easily. Thank you.